We have a vector field, and we're going to compute both the divergence and the curl. So we'll start with the easier one, the divergence. To find the divergence, we find the x derivative of the x component plus the y derivative of the y component plus the z derivative of the z component. And that looks like z plus xy plus 0. So there we have it. That is the divergence. The divergence is much simpler than the curl. The curl is the other derivative that we can take. And if the divergence is like a dot product, right, a sum of products of components, then the curl is like a cross product. So the cross product or the curl here is I, j, k, partial derivative with respect to x, with respect to y, with respect to z, and then the components of our vector field that we're going to actually differentiate, xz, xyz, and minus y squared. So, and then we compute this curl as if it were a cross product, and when we're multiplying terms like this together, it's actually the derivative, right? We take the derivative with respect to x of that term. So this looks like we do the I component just like a cross product. You know, as if it were a cross product, we kind of blank out that row and column, and we're left with this 2 by 2 matrix here, and we take the determinant of that, but instead of multiplying, we're taking derivatives. So the y derivative of negative y squared is negative 2y minus the z derivative here, so minus xy. The next term is a negative j. Remember, we switch signs for the j, and we're looking at blocking out the row and column containing j. So we have an x derivative of negative y squared, which is 0, minus a z derivative of xz, which is x, and then plus the k, and blocking out the row and column containing k, we have an x derivative of xyz, so that's yz, minus the y derivative of xy, so that's 0. And we have it in our ijk notation. Just to finish it off in our bracket notation, this vector looks like we have negative 2y minus xy, comma x, we had the negative x, and then we have the yz for the z component. So that is our curl. This was our divergence, and we've taken both of our vector derivatives of this vector field.